Hi and welcome to video 2. In this video I'm going to go through 5 different questions which will represent a range of different options for combinations and permutations questions. They are taken from the extra exercises in your textbook, the PDF version, so they will be specifically related to 6.2, 3 or 4, and I'll be showing you how to work out which one is which. So let's have a look at the first one. In how many ways can 5 people be arranged in a row? Typically, the word arranged is a little bit of a giveaway. If something's being arranged, then order does matter, and that implies it's a permutation. So 5 people arranged in one row gives 5p5. 5p5, which equals 5 factorial over 5 minus 5 factorial, which equals 5 times 4 times 3 times 2 times 1, which is of course 120. So be careful there that you know we're dealing with a permutation, but even if you mistake that for a combination, you should still be saying I have 5 people and I need to choose 5 people, and as a combination that will give you 1, which should be obviously wrong. So be looking out for that. Second question. For one exam, students are given 5 possible questions before the exam, but only 2 are actually examined. How many different possible exams are there? Now let's just imagine for a second that we have 5 possible questions. Question A, B, C, D, and E. If, for example, question D is chosen and then question C is chosen, well, that would be the same as choosing question C and question D in the context of an exam. So in this question, order does not matter. Order doesn't matter. So we're dealing with a combination. And now it gets a bit easier. Not only are we dealing with a combination, but we have 5 questions, we're choosing 2. That as a combination is equal to 10. Again, just think through the context like I've done over here. That will allow you to consider the importance of order. And once you've got the importance of order sorted, you'll be able to select P or C correctly. Question 3, and here's where I have maybe should have done my homework a little bit, but let's see how we go. A formal committee of 5 is to be selected from 12 nominations. 7 girls and 5 boys have been nominated. The principal of the school has stated there must be a balance of boys and girls on the committee. How many possible committees are there? So we are choosing 5. Now we're choosing 5 rather than arranging 5. The first person chosen is just as important as the 4th person chosen. So therefore it is a combination again. I don't know why I'm writing this at the top, but I'm going to. So this is a combination. I'm choosing 5 out of the 12, but it's not quite that simple. I need to make sure I've got an even number of boys and girls out of the 7 girls and the 5 boys. But it says even number, but I'm choosing 5. So this is where things get a little bit more confusing. So what I'm going to do instead is have a look at the 2 options where I break it down 2 boys, 3 girls, or 3 boys, 2 girls. So there are 2 options now. And the first option will have us choose 2 boys. So it will be 5 choose 2 times choosing 3 girls. 7 choose 3. And the second option, so we add the 2 options together, 5 choose 3 times 7 choose 2, 2 girls. And now we need to go through and calculate this. So this is 5 factorial over 3 factorial 2 factorial times 7 factorial over 4 factorial 3 factorial plus 5 factorial over 3 factorial 2 factorial times 7 factorial over 5 factorial 2 factorial. And this is equal to the 5 and the 3 factorial there will cancel out to be 5 times 4 over 2 times 1. 7 and the 4 will make it 7 times 6 times 5 over 3 times 2 times 1. Plus over here I get 5 times 4 over 2 times 1 again, times 7 times 6 because it cancels that with the 5 factorial, times 2 times 1. Just doing some simple simplification here. 3 and a 2 will cancel out the 6. I don't care about the 1s. 2, all the denominators are gone, and my answer is 5 times 2 is 10. 7 times 5 is 35. Plus 10 times 21. And that, of course, is 350 plus 210, which is 560. I didn't draw this out deliberately to annoy you. It is good for you to see this understanding here, but it's not necessary in all cases to actually show that understanding in the exam. You can use your calculator. I also drew it out a little bit because I don't have a calculator with me and I needed to do that. Question 4. 3 couples decide to go to the concert together. One person buys all 6 tickets. If the tickets for adjacent seats, find the probability if a ticket is given out at random, each person will be seated with his or her partner. So we have 3 partners. We'll call them A1, A2, B1, B2, C1, C2. And they are seated randomly in 6 seats, such as A2, B1, B2, C2, A1, C1 would be an example. And in that case, the B couple are put together, but the A and the C couple are not. We want to find the probability of all the random events that all the partners are sat together. So for that probability that all partners are together will be equal to the number of ways of being together divided by the number of ways. So let's start with the number of ways. We have 6 people and we are putting them in order. We're arranging them into 6 seats. So that will be 6p6, which is equal to 6 factorial, which equals 720 ways of arranging 6 people. Then we have the top, which is number of ways of getting those people together. So this is where things get a little bit trickier. But let's consider those couples as one entity. Let's consider that we actually have A, B, and C. If we actually have A, B, and C, we just need to think about how many ways there are of ordering A, B, and C. So the number of ways of ordering A, B, and C are 3 ways of choosing the first times 2 ways of choosing the second times 1 way of choosing the third. And this is actually 3p3. We're arranging the 3 people into 3 groups. But we also have to multiply this by something else. And that something else is to multiply by the number of ways that we could rotate the different people, the different couples around. Okay? So the ways of having the couples will be 3, pick 3, we're arranging them, multiplied by 2, choose 2 for couple 1, times, 2, choose 1 for couple 1. How many ways are there putting one of the people in the couple? 2, choose 1 for couple 2, and 2, choose 1 for couple 3. Obviously, these are just representing the number of ways of ordering A1 and A2. So this is 2 times 2 times 2. Couple A here, couple B here, and couple C there. And 3p3 is 6. So therefore, there are 24 successful ways. And ultimately, this means that the probability is equal to 24 over 720, which isn't the answer I should get. That would be because it's 6 times 2 times 2 times 2, which is not 24 indeed, it is 48. 48, which is equal to 1 over 15. And there's your answer there. So the important measure here is to make sure that you get your simple arithmetic right, otherwise you're going to look a fool, such as I just did. Last question. A bank teller has a bag of mixed Australian coins. How many coins must she take out to be sure of obtaining 4 of the same denomination? Australian coins. $2, $1, 50 cents, 20 cents, 10 cents, 5 cents. If you don't know what the Australian coins are, this question is not an issue. You can just make an assumption. So you just write down all the Australian coins you can think of, and then you assume that that is right. In an exam, I understand that at times context will be outside of your range of knowledge, and that's reasonable. As long as your assumption doesn't oversimplify the question, that won't be an issue. Now, is this question a combination or a permutation? It's actually neither. This is the one question from 6.4. This is just simply a counting principle. How many coins must she take out to be sure of obtaining 4 of the same denomination? Well, she needs to take out, I think we need to start thinking about some options. Imagine if she took out 10. 10 coins would mean that she could have 2 $2, 2 $1, 2 50-cent coins, 2 20-cent coins, and 2 10-cent coins, which would not be 4 of each. So now we're thinking, how do we get to 4 of each? Well, obviously, if I had 24 coins, well, this would mean that I could have 4 of every single one, which would give me 4 of each. And it's not actually 4 of each we're looking for. To be sure of obtaining 4 of the same denomination just once. So 24 would be successful. I could get 4 of each. And 24, if I took each of them down to 3 instead of 4, would increase one of the other ones to still have 24 coins, which means that there is no way I could have 24 coins and not have at least 4 of one of them. In fact, I'm more likely to have 5 or 6 of one of them. So 24 definitely works. 10, I found a counterexample. Remember, this question says, how many coins must you take out to be sure? Any counterexample negates the be sure aspect of this question. So now what I need to do is I need to find the highest possible number which gives me a counterexample. And in that case, that's 18. And in 18, I can get 3 times each type, because there are, of course, 6 types of Australian coins. So I could, with 18 coins, I could get lucky and end up with exactly 3 of each type. But if I have one more coin, and it's an Australian coin, it has to fall into one of these 6 categories, which means it has to create a set of 4. So 19 is the first non-counterexample answer. 19 is the answer you're looking for. And that's all the questions I have. So that is a mixed bag, such as this coin, set of questions from the exercises. Use these examples to go back to what you're doing. Make sure that you are able to identify if we're dealing with permutations or combinations. That's the most important thing here. Identifying that, and then you'll be fine. Understand each of the formulas, and you won't have an issue. If you have any other questions, please feel free to email me.